Mono, physics again. Is that motion in 2 dimensions up there?
Yes, I'd like to go over with you a question in motion in 2 dimensions, which is a projectile, and it's going to have multiple parts. Let's have a look. This could be anything you want it to be. It could be a football, it could be a rocket being launched, but as you can see, we're going to launch something at a 30-degree angle at a velocity of 23 meters per second. Now, I'm going to ask you multiple things, but before we do anything, I want you to remember, one of the key things to this problem is to understand there's going to be 2 types of accelerations. Because we're in 2 dimensions, there's going to be an x and a y. Never forget, acceleration is always downward. So it's going to be in the y direction, and it's always going to be negative 9.8 meters per second squared. I'm going to use that number here on the actual exam. You can use minus 10. And because it's just going downward, the acceleration in the x direction in problems in projectile motion, ax would equal 0. Okay, let's get a and b together. Find the initial velocity in the x direction and the initial velocity in the y direction. Pretty straightforward. In the x direction, if you dropped a little perpendicular down to here, you can see this is the x-axis and this is the y-axis. So we're going to take the horizontal component of the velocity first, and that's going to be, because it's adjacent to the angle, we use cosine. So the initial velocity in the x direction is 23 times the cosine of 30 degrees, which is 0.87. That'll be provided on the OAT exam. And we get 20 meters per second for the velocity in the x direction. The y direction, as you can see, the y-axis is opposite the angle, so we're going to use sine. 23, sine of 30, we all know is a half, so you get 11.5 meters per second. So these are your 2 velocity components. How about C? What would be the time to the top and the total time? Here's the trick to this. First of all, at the top of the projectile, as you can see, watch the motion. As you can see, the motion is going to go in the x direction. So the velocity in the y direction is 0 at the top, but the x never changes. So therefore, the x velocity at the top would be 20 meters per second. That's tricky. So there's 2 answers for the velocity at the top. 0 in the y, and it would be 20 in the x direction because the velocity never changes in the x direction. What would be the time to the top? Well, I'm going to use the acceleration formula to get to the top. So I'm going to write acceleration as v final minus v initial over time, but I'm in the y direction because that's where the acceleration is. So always use the y component of the acceleration. So it's negative 9.8. The final velocity in the y direction we saw was 0. The initial was 11.5. Solving gives me the time to the top, 1.2 seconds to the top. Well, I'm going to show you a little trick, but you can only use this trick if you're on level ground. Double the time to the top for the total flight time. So it's going to be 2 times 1.2 or 2.4 seconds. But remember, you can only double the time when you're on level ground. If you were on a cliff, then it becomes more involved and you need a quadratic equation. So remember, double the time to the top gives you the total time if you're on level ground. Part D, we already did. That was the velocity at the top. Y component is 0. X is the 20 meters per second. Part E, what's the maximum height? Well, obviously, the maximum height is going to be determined by the time to the top. So I'm going to write the distance formula. S is 1/2 AT squared plus VIT. Put your little y to remember you're in the y direction. 1/2. Always use negative. Never forget that because acceleration is downward. There's the time, but I'm using the time to the top squared. There's the VIY. There was the component of the velocity in the y direction. The time gives me 6.7 meters when you figure it out. So you can see if you forgot that negative sign, you would add a positive here and it would have been curtains. What would be the range? Well, what exactly is the range? The range represents the displacement along the x-axis. Is how far you are from this point to this point. So to get the range, we're going to get Sx. So S of x is 1/2 ax t squared plus vixt. Ax, as you remembered, acceleration is 0 in projectile motion, since it's only in the y direction. Vix, we got from up here, is 20. And to get the range, you're using the total time, right? Because it's from this point to this point, you're going in this direction. So when you do it, you come up with 48 meters. And there you have it. Those are the most commonly asked questions on projectiles. If you can know this, I think you got yourself covered for projectile motion.
Thank you, Dr. Romano. You make it look so easy. I've got to get to work. Will you be doing some more physics?
We'll do a lot more physics. Good day to you.
Good day to you, sir. Have a good one.